Hello everyone, my name is Rajarshi Roy and I am currently pursuing BTech from Kalyani Government Engineering College in the Department of Computer Science and Engineering. Recently, I have posted about my progress in learning the theory concepts of machine learning, deep learning, and generative AI like LLMs. And now I am using practical approaches to understand and implement data science projects. So I would like to share today one of my projects, house price recommendation, rate and recommendation system. Basically, what it does, one minute. It is deployed in AWS. I have used GitHub Actions for it. So what it does that I would give it few inputs like this. Okay, and then it would predict that how much the price can be, the range of it, and similar types of properties from the dataset that I have collected. I am using cosine-similarity for this purpose. It is 44% similar. I haven't used images for this. If I use that, then I would have used scraping tools for using its particular images for the particular properties. Besides that, here is the code. Uh, I have used this particular project template structure from this GitHub repo. Krishna Xer's disease classification deep learning project and this video. I have referred it and I have attached this reference in my own GitHub repo. Here is the previous house preparation playlist. I have referred this for understanding how we use the prediction systems for understanding the linear or supervised prediction techniques. Here is a full playlist on it. And this one is the video of the project, and this one is the GitHub repo, which I have already shown. This is my own GitHub repo of my project. This project is a little different from this project, but I have referred the project structure from this project. So here is the config file. Everything is a data ingestion. Where is the path? This artifacts structure is not given in the GitHub repo because it would take too much space, and I don't particularly need it for deployment purposes. And there are model. This model structure, this model rent model, because the model for the rented properties and housing properties are very vastly different in scaling. That's why I have used different models for renting and buying data sets. And there is also processor. I have added this separately because I would need them in deployment purposes. Then there is the recommend data set. This CSV file is particularly used for the cosine similarity when I would use the recommendation system, which is this part. Here is the research section. These are the Jupyter notebooks, which where I would experiment my code and then add these things in their particular order. Like here is the configuration API. Here's the data model training. Here's the data transformation. One other thing I have here in model trainer, I have implemented the ML flow. Here it would track my ML flow, my model experiments, what I have done, and my model scores. Here is the in dataset. Here you can see my experiments. This one is for the model with buying and rented properties. This one is for rented properties. I think I can get even better accuracy by using ANNs, but I haven't implemented it yet. If I consider progressing in it, then I would surely share that progress in my LinkedIn post. So coming back to the code, here is the configuration, here is the constants, the config file and params file that we would need in the project. config and entity, and here is all the pipeline stages. As I said about the images, if I had to give images for the particular properties in the particular according to the data, then I would need to scrape them with this scraping pipeline. But it would be a tedious process and not very necessary. That's why I skipped it. But here is still the code if anybody wants to replicate it and use it for their purpose um, of their project. Um, Here is the predict and recommend pipeline. Basically, here is the recommended system. Okay. And then here are the utils, exception, and common that we need sometimes. The transformer, setup. Here is the static folders. Here is the template. Then app.py. This is the particular flask which is responsible for the deployment of my project. It is a little bit I didn't know that how I may use this feature. That's why I've used this type of thing. Basically, what I wanted to do by this code is to have this. Until I select one option from here, from city, I can't choose anything for the according city location. So I would consider first Patna city, then here I would see the localities according to Patna city. If I change it to any other thing, Gandhinagar, then I would get the localities according to that city. That is what I try to implement from these two code. Then here is the train, the main.py, which I would come to in the next part. Here is the main hosting by this. Here is the Docker file. Here is the DVC YAML. I have used this for the DVC. That's why these artifacts are handled by this DVC, but I haven't used this to be tracked by the DVC because I need them in the main GitHub repo. Then after DVC, I have params or YAML. Basically, in this YAML, I tried to include models as a feature that uh, by here only I can directly choose what models I want to use and what models I don't want to use, what features I want in them. I have used only this decision tree criteria and that boost regressor for this particular purpose. Here is the README, which you would see in the GitHub repo. These are the requirements, setup, template file, and main.py. Here is the main.py. This main.py is responsible for running the pipelines in this particular order, which I have implemented: data ingestion, then data transformer, which I would show here. Python main.py. Just wait a minute. It's taking a little more than usual. Because by the time it happens, I just show you this. This is implemented through AWS EC2, and I have also used ECR for container registry. Here is my GitHub Actions. This is my GitHub repo. Here is the actions. Sorry. Here you can see the continuous integration and delivery deployment. All are occurs smoothly. Okay. Here you can see it is running. First, stage 1 data ingestion started. Then after that, when it's completed, um, here it's completed. Then second stage data transformation stage started. Then here you see the preprocessor file, how it looks. Then it's completed here. Then model trainer started here. This is how my data looks like in the bank. Here it's taking some time because it is also using cat boost regressor, also decision tree regressor. So it's going to take a little more time for the display purposes. So here you can see continuous delivery. It's using Amazon ECR for the um, image building purposes, and then it's posting here. Then in deployment, it is pulling the latest image, then running the Docker. Okay, here you can see decision tree gives 82%, cat boost regressor gives 88% of accuracy. This was the first part. After that, the running one, the model on running dataset would start. This version. This part is showing the ML flow tracking model registry. I have used ML flow, used GitHub CI/CD pipelines. Here is it. Here it is. GitHub CI/CD pipelines and AWS for cloud. Here you can see the by Docker PS that which Docker image is running. This image is running in 8080 port, which you can see here. What happened? In 8080 port, this, and in something happening. Okay, fine. By Docker logs, we can see that what's going on in the class, that it's executing perfectly, and that's why we can see this port running smoothly here. And here, decision tree gives 43% of accuracy, cat boost regressor gives 68% of accuracy, which is not really great, but okay, we can improve upon it. But just to show what this project looks like and how I am using MLOps tools in this particular project, I have used all these things inspired by Krishna X's instructions and their videos and GitHub repos. That's all I have to say about this project. Thank you for being to the end, until the end. I would keep posting about my progress on this data science ML ops journey. Thank you for your patience. And please pardon some of my silly grammatical mistakes while speaking. Thank you.